Here we're going to develop the first law of thermodynamics, and the first thing we need to do before we do that is define a couple more things. And the first one is internal energy, which is essentially the energy in a system that's attributed to the molecular motion. So these things shake around, right, and there's some energy in there. And this is essentially energy that's not either kinetic energy nor gravitational potential energy. And it is a property of the system in that it is independent of process. You know, if I have a state that I'm in, that system has a specific internal energy with it, okay? So the total change of energy is not only the change in kinetic energy and the change in potential energy, but it's also this change in internal energy, which is actually the most important form of energy and most significant form of energy we look at in thermodynamics. So again, delta U is the change in internal energy, which along with the change in kinetic energy and the change in potential energy give us the total change in energy that we have. Okay, so that's kind of the final property we need to describe when it comes to energy to come up with the first law of thermodynamics. Now, one more thing attributed to a process is heat, which is different than work. It's still a transfer of energy due to the process, but it comes through conduction, convection, radiation. Okay, those are the three types of heat transfer that we have. Okay, now in this course, we're not so concerned about how that heat transfer occurs. We're just interested in that it does occur. Okay, now again, this is not a property. This is within the process. It depends on the process. So between sets of properties or states, right, you have some amount of work, some amount of heat that changes the state, changes those properties. Okay, and that heat is part of the process, similar to how work is. So it has the same units as work, has the same units as energy. Okay, now the sign convention, this is very important, is the reverse of work, in that a heat transfer to the system is actually positive, whereas heat transfer from the system is negative. Remember, work is positive when it does work on the system. When work is done on the system, it's negative work. When work is done by the system on the surrounding, it's negative. So heat is the opposite of that. Again, positive Q is heat transfer to the system. Negative Q is heat transfer from the system to the surroundings. Okay, and that will come into play when we get to our energy balance here in a second. One last definition is this idea of an adiabatic process. An adiabatic process is a process where no heat transfer occurs with the surroundings. Okay, not to be confused with isothermal processes when there's a constant temperature. Okay, they're not the same thing. You can have a change in temperature, but no heat transfer with the surroundings. Okay. Similarly, you can have heat transfer, but no change in temperature. Okay. So they're not the same thing. They are different processes. Adiabatic is different than isothermal. Adiabatic is when basically Q equals 0. Now, this finally leaves this boxed-in equation is our first law of thermodynamics, and it's an energy balance, in that the total change in energy, which includes both the internal energy, potential energy, and kinetic energy, is equal to the heat into the system minus the work out of the system. Now, remember that sign convention, they're backwards, right? Q is reverse of W. That's why that negative sign is here with the W. Okay, so Q in adds energy to the system. Work out takes energy from the system, but we're calling work out positive. That's why we have that negative, because it's actually taking energy away from the system. But based on how thermodynamics, you take heat, you burn coal, you put it in the system, and you get work out. That's why we call work out positive, even though it leads to this negative sign in our energy balance. So just be aware of our sign convention when doing this. We also have a time rate of form. It's basically just the time derivative. So dE dt, which is as shown there, is just Q dot minus W dot. Again, where Q dot is dQ dt, W dot is dW dt. Okay, but this is our first law of thermodynamics. In effect, the change in energy is heat in minus work out.